recording. We are recording. So just before then, we just said, okay, this is where we left off here. We're rewriting this one as 1 over x to the 6. As Krista said, is that 1 over x to the 6 can be rewritten as x to the power of -6. So we've rewritten the original functions. We haven't integrated yet. Now we're going to integrate. Here we go. All right. So this one here, x to the 1/3. What's 1/3 plus 1?
4 over 3.
Good, yeah, x to the 4/3. How did you get that?
You put it in 1.
Yeah, exactly. It's like 3 3s plus 1 3. 3/3 plus 1/3 is 4/3, yeah. And then, same thing, I tend to do this first, and then my next step I kind of do 3 over, dividing by fractions, the same as multiplying by the reciprocal. So on the next step I tend to do 3/4 times. So 3/4, I'm not going to say, so 3.
Isn't it 4 times 3 times 3 is 4? Well, it doesn't matter.
Wow, look at this board. What's that? There's somewhere writing that is the board. That, by the way, what does that say? Good question.
3x over 3 over 4 plus
Yes.
c.
Plus c, yes. So because dividing by 4 over 3 is the same as timesing by 3/4. So I times the whole thing by 3/4, and the board's a bit funky. So you could have written the middle step before this, and then the final answer would be that. The board just got a bit funky, so I just decided to just go write the answer while I could. So 3/4. Yeah, 3/4 times x to the 4 over 3 is 3x 4 over 3 over 4. And then plus c is outside of that fraction. Now, interesting. X to the 3/4. What is 3/4 plus 1?
7 quarters.
How did you get that?
I added 1.
Add 1, yeah. But still, like, how did you get a 7?
4 over 4, so then 4 plus 3 equals 7.
Yeah, 4 fourths plus 3 4/4. Yeah, 3 plus 7 4. That's how you did it, just in case anyone's wondering. That's how we get it. Okay, so we would end up with x to the 7/4. And what do we divide by? Over 7/4. Yeah, plus 7. Let's keep that plus c going.
4x.
Good. Oh yeah, so and then dividing by 7/4 is the same as times, right?
4 7.
4 7s, yeah, which would make it in the end.
4x 7 over 4 over 7 plus c.
So again, you could have shown a middle step if you wanted to, where you kind of 4 7s times x to the 7 over 4. So don't like I'm having 4 7s. No. X to the -6 is a bit nicer. What's -6 plus 1?
X to the minus 5.
Oh, I can't trick you. I was thinking you were going to say -7.
No, that would be some.
The x is on the time track.
Okay, yeah.
It's on drive.
X to the minus. I was about to write -7. X to the -7. Divide by? Oh, -5, sorry. X to the -5.
Divide by minus 5.
Divide by minus 5.
Plus c.
Yeah, which I suppose that's technically not wrong, is it? But like, how could we? I would tend to write it as yeah. Oh yeah, you could do that. Yeah, that's true, and that's fine. If the question didn't say write it with positive exponents, that's all good. What if they wanted positive exponents only in your answer?
Sorry, what was the question?
Yeah. So you can see how x to the -6 is the same as 1 over x.
We have to like, we flip it. So it's 1.
Yeah.
What?
5 x to the 5.
No, 5 over x.
Oh, yeah, to the 5.
Negative 5
5 x to the 5.
Yeah, and if they didn't require positive exponents, then this would have been that would have been fine. So it's only if they wanted positive exponents. That's fine without positive exponents. If they want it, you could do that. They might, because sometimes textbooks don't like you to have the negative at the front. They might have written it as c minus 1 over 5x to the 5. Holy moly. So, and you can double check it. Let's double check it. If we differentiated this purple, negative x to the -5 over 5, if we differentiated that, would we get x to the -6? Let's double check that. So negative 5 times negative 1.
Make 5.
So that would make us 5x to the negative 6 over 5. 5x to the negative 6 over 5 would simplify to x to the minus 6, wouldn't it? So see how you could double check it. You could like if it was starting to seem a bit weird to you, you could double check it by seeing if it differentiates.
I'm confused as to how you move from these first to these second steps.
The green one to the purple.
Yeah.
So green one to the purple. Yeah. Oh, so this is nothing's wrong with this. It's just like, you know, sometimes they don't write that in the textbook. This could have been the answer totally, the green one at the top. But in the textbook, quite often they, rather than put the negative in the denominator or the numerator, they'll just pop it out the front. Because a positive divided by a negative overall gives you a negative. So what I meant to do in the purple line, I just meant to put the negative out the front of the fraction in general. Because I've noticed textbooks tend to do that. So just showing you that that green thing is the same as that purple thing. And they in the textbook might have written it as C minus 1 over 5x to the 5. Because sometimes textbooks don't like, if there's a positive and a negative, sometimes they don't like the negative at the front. It just doesn't, it's not as nice to look at, that's all. It's just more awkward. Holy moly. So see, I've showed you two different ways of asking the same thing. The first one I said anti-differentiate the following. Then in the next one I said integrate the following, just showing you the different words we can use. I didn't use that funny symbol yet. And then in this one I said find the indefinite integral of the following. The indefinite integral just means your answer is just going to have plus c in it. So a definite integral would be one like Hiesha was asking about. A definite integral would be where we give you this and we also give you a coordinate on the original function and get you to sub it in and solve for c. That would be more of a definite or defined integral, or maybe we'll tell you over which two boundaries or something like that, over which two numbers. Don't worry, you probably don't understand what that means. So find the indefinite integral just means do what you were doing up here. That's all. Just you're going to have plus c in the answer. That's all, more so what it is. So this little symbol here means integrate. That's a little universal symbol to mean find the antiderivative to integrate. Dx just means with respect to x. So the dx just means with respect to x. So you notice they all have dx written on them. The dx isn't part of the function. It just means with respect to x. So if my function had t in it instead of x, it would say dt. If my function had w in it instead, it would say dw. If it had something else, it would have, like, you know, another letter like I, it would say di. So it just means with respect to x is all that dx means. So don't be fooled by that dx. Don't think it's part of the function. It's not. Pretend it's not there for now. It's just a formality that has to be there. Because maybe you might, in later years, if you studied more further calculus, you might have kind of like functions where they've got more than one variable, and that's why they specifically would then have to tell you which variable they want you to integrate it in relation to. Like if you had a t and a x in there, dx means integrate it with respect to x, not with respect to t. So it's just a formality thing. So it's like this little funny s. What did you guys call it again? Like tweak, the tweak, yeah. So the little tweak, instead let's call it the tweak, because I can't remember what the proper name for it is. There probably is one. And then the dx just go together. So the function technically is just 10x to the 0.2. That's what the function was. So this function doesn't mean find the derivative, it means integrate, do the opposite step. So our answer is going to have plus c in it. What will be the new exponent?
1.2.
Good. How did you get 1.2? Add 1 to the 0.2, yep. So it's going to be, start with just 10x to the 1.2. What do you divide by?
1.2.
1.2. What have I forgotten?
Wait, but plus c.
Plus c, yeah. Really easy to forget the plus c. Huh? Yeah, that would simplify. Like, you know, 10 divided by 1.2 might give you a whole number. It might give you, yeah, it does it? No. Does it? No. No. Or it might just give you a decimal or a simplified fraction or something like that.
Wait, but Miss Marie, how would that cancel out? Because wouldn't 1.2 times 10 be 10.2? So that would have canceled out?
Yeah, and 10.2 divided by 1.2 gives you 10. Oh, hang on, wait, no. It gives you
Because you divide by 1.2 because you would have spent.
Oh, sorry, no, it gives you 12. I get you, yeah. Sorry, 1.2 times 10 gives you 12. And 12 divided by 1.2 would give you 10.
Okay.
Yeah, I get you, yeah. So that Krista was just double checking the reverse step. Does the reverse step work? So 10 divided by 1.2, we simplify that. We could use a calculator, or we could think. Okay, roughly how many times, if it was 10 over 12, what would it simplify to? 5 over 6. So maybe it could be like 50x over 6, then simplify 25x over 3.
Yeah.
Yeah.
Oh, it's divide. 10 divided by 12. Let's see, what does it equal? Yeah, what's 10 divided by 1.2 equal to? Yeah, slightly annoying.
10 divided by 1.2.
Yeah, 10 divided by 1.2.
8.3 recurring.
8.3 recurring, what's that as a fraction?
25 over 3.
It is 25 over 3. So yeah, it's all good. Alright, let's just go.
Yeah, it is, pal.
Just because the recurring was awkward. Like putting 8.3 recurring, that's a coefficient, just feels a bit awkward.
But Miss Helen, when you simplify things, are you trying to make this simpler?
No, you're trying to make what's the bottom thing called?
The
denominator?
Not have it as.
Yeah, okay, I see what you mean, yeah. So see, in a way what I did in my head, I kind of did 10 divided by 1.2. Okay, if I times the top and bottom by 10, I would get 100 over 12. And then I just started to simplify that. So I times,
So you
divide it by 4.
yeah,
But why did you need to do
which
that?
is 50 over 6, which equals 25 over 3. Because 10, like, you know, when we write a fraction as its final answer, it's not supposed to have a decimal in it.
Okay.
Yeah, so a fraction, the math gods, the math number gods, have just stated that in a fraction they don't like there to be a decimal so much in a final answer.
How do you talk to them, math god?
I talked to them through Derek, well, we unicorn.
That's funny.
Is Derek the math god?
No, he's just more like a medium.
He's a prophet.
It's going to be very weak for page, you know. They don't understand what Derek really means.
And Owen, you always forget about Owen, but you know Owen said page Calvin. You can't forget about Owen. He loves to pick on Owen.
Oh. Okay, so now.
Owen's gonna be watching this like such a face now.
Oh. Okay, so nice. So that's all good. It's done. But the good thing about that, see the previous one, technically numerically right, but as I said, the math gods don't like there being decimals in a fraction. So by what I just did before, I turned the fraction into a simplified fraction with whole numbers as coefficients. It's fine for the exponent to be 1.2. You can change that to a fraction if you want. What's 1.2 as a fraction?
1.2 over 1.
Which simplifies to? If you're not sure, yeah, 1.2 over 1.
0.6 and
0.67.
Times the top and bottom by 10.
12 over
Which simplifies to?
4, 5, 6, 5.
Yeah, 16. So instead of 1.2, you could have written 16 as well. The main thing is, yeah, the algebra gods don't like that decimal in there. Okay, so this thing again, notice that the function is just this bit in here, not the dx, not the twin. We might need to rewrite the original function first. That might be a good idea.
What's that? 1 x over 3 over 5, so would it be negative 3 over 5?
Yeah, good. Nice, you can. Okay. That was fast.
man.
Oh. I'm just trying to write it here instead.
I wonder what work I'm going to do my free next period. I wonder what work should I do my free next period.
So, Krista, you were right. X to the negative 3/5. And we're just going to get you to explain to us. How did you get that? And you're totally right. X to the power of negative 3/5.
I just looked at the denominator and I said, well, the fifth root of x to the cube. So then I did, it must be x to the power of 3 over 5. But Erin saw that it was in the denominator of the fraction. Therefore, it has to be a reciprocal, so it's negative 3 over 5.
Yay. Well explained. Kind of similar to like how 1 over x to the 6 became that one. Yay, well done.
I miss Canada.
Alrighty, so now awkwardness. What's negative 3/5 plus 1? What's negative 3/5 plus 1?
2 over 5. 2 over 5.
No, it's not negative.
It's 2 over 5.
So it'll be positive.
Because 5 over 5, negative 3 plus 5 over 5 is 2 over 5.
Yep, so negative 3/5 plus 5/5. Yep, is 2/5. Yep. So it's x to the power of 2/5. What do we divide it by?
2/5.
2/5. Yeah, don't forget your little plus c. Do like me. There. Now what's 5 over 2 times x to the 2/5 just become?
5x to the 5 over 2 plus c.
Plus C.
Well done, plus c. Yeah, nice. I could save this for now, so in case something goes wrong. Give
What
myself
did you
a bit
just
more
add?
space. Oh, it was like x to the 2/5
Yeah.
divide by 2/5. It means x to the 2/5 times 5 over 2. So how would you therefore write the final answer, kind of thing, like in a nice way? You could have written 5 over 2 and then x to the 2/5 next to it, but you know it's good just to be aware that you can write it like this. I personally find this a bit easier to write it as, but it's not wrong if you wrote 5 over 2 and then x to the 2/5 next to it plus c. Oh, this is nice straight up one. So yeah, what would be the new exponent? What would be the new exponent?
You just like couldn't remember this for living.
3x negative 1
3x to the negative 1. So what do we divide it by?
over negative
What did I forget to write?
plus c.
Yeah, because if I don't write that plus c, I'll probably forget it in my final one. I think strategy. Strategies. We can, so that's technically numerically kind of right. But
The math god.
yeah, what's 3 divided by negative 1?
Negative 3.
Negative 3.
Yeah, so you could start to write it as negative 3x to the negative 1 plus c. If the question is fine with you having negative exponents, no props, you've got the answer. If the question said no negative exponents, how would you write the answer?
Flip it.
Negative 1
3x.
over 3x to the power of 4.
Close?
Negative 3x.
One
Negative
over
3 over
3x.
x 1.
And then negative in front.
Yeah. So yeah, does the negative 1 belong to the x or to the 3 and the x? Just to the x, yeah, exactly, yeah. So yeah, all good different ways you can write it. Negative, yeah, 3 over x. Is that what you just said? Something like that.
No, I answered that.
What did you say?
Wait a I meant that too.
Oh, okay, yeah. You might have said to x to the 1, that's fine, because you were just trying to say what you meant.
Wait, Miss Melanie, so can you put the negative in the numerator if you wanted to?
Yeah, you could. You could write it like negative 3
Yeah.
over x, yeah, plus c, yeah. That's not too wrong. It's just odd to see. It's odd to see. It's odd to see the negative written in the denominator. That's all. I think the textbook will tend to kind of write it like my bottom answer there, just so you can understand what the textbook is. Holy moly! So, I should have had brackets. I went to write a bracket in the most completely different spot to this. So I was meant to put a bracket around here. You see it's kind of got multiple terms in it. So you might just want to, I was meant to have written a bracket around there. See, these were just kind of more like single terms, so I didn't need the bracket. When you've kind of got multiple things together, you tend to put a bracket on it. So you'll probably notice from now on I'll have had a bracket on there. Same in the textbook. It doesn't mean anything different, it just means that whole thing functions. Nice. This is nice, it's just there's a few terms. So we've just got to do them all. 3x to the 4.
3x to the 5.
Over, yeah, good. 3x to the 5 over.
5.
5, yeah, good. 2x.
2x to the 5. 2.
Good. Over? Good. Yeah, over 2. So let's do all this as a first step. Minus 5. Very good. Yeah, minus 5x. And then what have I forgotten?
Plus C.
Plus C, yeah. Because see how when you've got multiple terms, it can be easy to forget the plus C.
Is that because C is like the number that doesn't have an X?
Yeah, exactly. So this would have been like a 7 or a 1, or it could have been a negative 3. Because when you differentiate,
You know what constant is?
yeah, because when you
Basically,
differentiate a
what
constant, when you differentiate a constant, it's just in the answer it's not going.
Basically,
Constant could have been 0 for all we know.
so we're not adding 1, we're adding actually
That's the
called
one
1.
that gets yelled at.
So when we have to take it wrong on 1.
We're adding 1 to the exponent, you mean?
Yeah, so you didn't like, you wouldn't add 1 to 5, you add actually called. Right? Right?
Oh, you're talking about that one.
Yeah.
Yeah, okay, yeah. Because technically, think of that, think the negative 5 as being 5x to the 0. Like,
Yes,
this
extra is 1, yeah.
And then so you can add 1 to that exponent, would make it negative 5x to the 1 over 1. But rather than bother to do that, we kind of just go, okay, it's just going to be 5x. Because 5x, when you differentiate it, will become 5. Okay, have we simplified it though? No. Is the first term okay?
Yeah.
Yeah. So that's okay. Let's just rewrite that one. 3x to the 5 over 5.
Yeah,
What about the next term?
It'll be x squared.
Yeah, good. Plus x squared, because the 2's cancel out. Plus x squared. What about the next two terms?
Same.
They're alright, yeah. And one like this, I think, to be honest, I probably would have written 3/5 x to the 5. I think we know, so it's okay to write like this. I think they would have written 3/5 x5 to the 5. Just because of the way it's set out. So, that is, no, there's another page, isn't there? There's another page. I was going to say, that's the end of this particular lesson. Anyone writing that down still?
No.
Next one. Here's the last page. Shh, guys. Why is so funny? Okay, no. 3, 2, 1. Okay, so back to who? So this is, notice some of this might look a bit, no. Okay, so some of this might look a little bit familiar, and same with this page. Here we go. And then the next page is the next bit, so.
Page must be that way.
Okay, back to here. So when we were doing regular calculus before, we had to kind of talk about velocity, acceleration, and displacement. So like differentiating, integrating or anti-differentiating can be applied to motion problems, e.g. problems to do with displacement. Yep. What's that? You have displacement, velocity, and acceleration. You see what that says? Acceleration. Okay, so velocity. Yes. So problems to do with displacement, velocity, and acceleration. That's what
It looks like it says arculation.
It's just okay. This kind of application is commonly found in the scientific physics, which is called. I'm not sure.
Kinematics.
Is it kinematics, isn't it? Yeah, kinematics.
Did you document something?
No, I just forgot. So I was thinking kinetics, yes, but that's kinetics is chemistry.
Yeah.
That's a thing in chemistry, like
Kinetic
rates of change, rates of.
Kinetic and
Oh, there's that too, yeah. And kinetics is a branch of chemistry that I had to study at universities. And kinetics was to do with rates of reactions. Like kinetics in chemistry is like increasing rates of reactions and things like using catalysts and all that kind of thing. Calculating the rate of reaction. But kinematics, you are right. For example, if velocity is the original function,
the OG funk.
yes, if it is the OG original function, then the integral will be the
Displacement.
displacement. It'll be the next one up. Yep, displacement. Displacement.
Can we do an explanation?
Which is like the vector of distance. Displacement is like distance, but it's like, sorry, what's that?
Velocity is the second one. So if it integrates, then it goes up one displacement.
Yeah, it's the opposite of differentiating.
It's like
You
if
go
you
up
look
one.
in purple, they're in order. So it's
Oh.
velocity and it goes.
Oh, it was the velocity distance. That's why. So why did you change it from distance to displacement, Miss Maloney? That's just annoying.
Okay. What?
Why you say displacement or not distance?
Oh, because displacement is a vector. Distance is a scalar. Scalar. Scalar just has magnitude. Vector has magnitude and direction. We'll learn vectors later. Like vectors is an actual topic in our course.
We haven't done that yet?
No.
We didn't add over 2 in your brackets.
Oh yeah, a little bit of that. Yeah, vectors is just a more complicated version of that.
Oh, great.
Yeah, but it's a nice topic. That's why we tend to do it later. Calculus is a huge topic in our course.
Calculus can step on my toe.
Okay, so if acceleration was the original function, then the integral would be the next one up. Yep, velocity. Oh, okay. Don't forget also, if the OG is velocity, then the derivative though. The derivative.
It would be acceleration.
Yeah, cool. Oops.
The lady in the presentation, her presentation was very interesting, but she's so soft-spoken. I got never more soft-spoken.
But didn't it make you listen more?
Yeah,
That's what I found. Like I was just,
very monotone. I walked away.
but I was
It was, I was so fascinating.
I know it's so cute because like she's gonna come back to Bermuda and then she can stay with her family and then go to lunch.
But remember she said I sent them. I know, it's like.
All right. Yep. All right. If the original function is the displacement, then the derivative would be the velocity. Yeah. So this last little bit here, this last little bit was kind of more so from the earlier year, the earlier class calculus. From earlier calculus, like as in chapter 6. So this stuff we're doing now is chapter 9, but this bit was just recapping back from chapter 6. So this was just pointing out that they're sort of the opposite. So, like Felicia, I've got a little picture here, displacement, velocity, acceleration. If I'm kind of going down like this, am I differentiating or integrating?
Differentiating.
Differentiate.
Differentiation.
Oh, what was that?
What is your differentiation?
Oh, yeah, I know. So, oh, no, I'm doing this.
Oh, yellow.
So, I'm just doing it wrong way. So, if I'm going the other way, what am I doing?
Integrating. Integrating.
Yeah, integrating, or you can also call it anti-differentiating. Integrating, or say another word is anti.
Why did I have 2 arcs for? Why can't I just stick with one?
Huh?
They can learn to teach them this mess.
Yeah, that's what really matters.
Yeah, I tend in Australia we tend to use the word integrate more. So that's why you'll notice I say it more. Australia. And the textbook's kind of got a mix of both. So that's why I thought, like, okay, let's just mix it up and put them both there. Anti-differentiating seems pretty obvious, like it's the opposite of differentiating. Integrating, you might forget that word.
Miss Maloney, I think you should talk to Cassandra because she has a nice Australian accent.
Who's Cassandra? Oh, Cassie. Yeah, she does it. I didn't know who you were talking about though. I thought you meant a real Australian. She can just do one. She can actually.
If she was really Australian, I wouldn't have said accent. But I understand.
Mm. Yeah.
Derek
Derek says yes. Hmm?
There's a real accent in there.
Derek is on the Derek came to the top of that. Where?
No,
It's real accent in there.
you can't open. Oh, you can open it.
Oh, sorry.
See?
Ugh, this is disgusting. There's stuff in there. That's gross. Okay, so all right. So let's apply our knowledge. So we've got 18 minutes. Good, yeah. Velocity v. What? ms minus 1. What does that mean? What's ms minus 1 mean?
Meters per second.
Yeah, it's just a physicsy way of saying meters per second. Lauren's got the stairs up. Okay, of a moving object at time 2 seconds is given by 2t squared minus 3t. What kind of function is that?
Quadratic.
It's quadratic. Out of interest, is it concave up or concave down?
Concave down.
down.
Yeah, is it smiling or frowning?
It's
Smiling.
Yeah, so that just means concave up.
Oh, I was right.
Yeah, meaning it's kind of, its arms are going upwards. And it's down rather than downwards, yeah. Concave up. What's its y? Out of interest, oh no, doing, yeah, fine, that's fine. How did you know it was concave up?
Because of the plus.
Yeah, yeah, that's right. The coefficient of the square, t squared is positive. Yeah, good. What is its y-intercept going to be? Just by looking at that.
We don't.
0. Yeah. If it was like +1, it would be 1. If it was -4 at the end, it'd be -4. But if it's nothing, it's just 0. So it's going to be kind of like, yeah. We're not sure what its x-intercept is. We'd have to factorize it and solve. So when t equals 3, the displacement of the object is 8 meters. So this is an example of one like Kiesya said, where this is a coordinate. Notice it's instead of x, they've got t. So they've given us a coordinate on the original function.
Isn't it 9?
Stop dragging your feet. How?
So see this thing? This is a little coordinate that fits onto the original displacement function.
Maybe it's literally, doesn't it equal 9 though?
9? What does what equal 9?
9 times 2 is 8.
Ah, but this is the velocity, not the displacement. That's a very good point. Yeah, if you subbed in 3 into here, it wouldn't match up with 8. But this thing refers to the displacement, which is the integral. So how do we get the displacement function? We
find the derivative.
close. Do we integrate or differentiate? Yeah, integrate. Yeah. Yeah, because we want to go from velocity, good. We want to go velocity to displacement. So we've got to integrate. We've got to go the next one up. So we need to make a little plan. Integrate this first. This first to get displacement. But when we get the displacement, we're going to have a plus c. We're going to be able to solve for plus c by stuffing in the coordinates. And then we'll have to find out what that c is. So fun. Yeah, good. So, oh yeah, yep. So s equals, yep, 2t. What's it?
3 over 3.
3 over 3, yeah.
Minus 3t2 over 3.
Yeah. Plus.
Plus a 3.
Close. At the moment. We don't know what the c is yet. So we're going to solve, we're going to sub in. See, they say that the displacement is 8. So we're going to sub in 8 for the displacement. We're going to sub in 3 for the time, and we're going to solve for c. And we'll probably get some awkward, horrible number. So let's sub in 8 for the displacement. I'll fill in the spacing. Yeah, and I'm just going to put them in blue, just to show you that we subbed it in. So what we've done is we've subbed in t is 3, and the other stuff is 8. So let's do a little bit of non-calc. Let's try non-calc for now, as much as we can. We're welcome to try with calc though.
So why did you put s? Doesn't that mean we're finding the displacement?
Yeah, so we integrated this first to get displacement. That's what we did here.
Yeah.
And then they've told us that when the time is 3, the displacement is 8. And so that's going to enable us to solve for c.
Yeah, so why'd you put s there?
Oh, s for, because they said s for displacement.
Okay.
Yeah, that's the only reason. Yeah, if they didn't say it, I would have just written the function or displacement equals. S is a commonly used letter for displacement.
That's irritating.
But yeah, normally because it's maths, you're not all expected to have done physics. They'll quite often put that in there for you.
Okay.
Yeah, so now I've got to work all this stuff out. What's 3 cubed times 2? Oh, actually,
18.
18.
No, we're wrong.
Oh, no,
So
no.
3 times 3 is 9 times 3 is 20, so 54.
27. I mean,
54.
what she said.
Wait, what? 3 times 3 is 9.
54.
3 times 3
Over 3.
3 times
which simplifies to a number, nice number.
3 cubed.
3 cubed is 27. 54 over 3 is what?
Well, you can simplify that first. What is 3 cubed divided by 3 going to be?
3 squared.
3 squared, which is
9.
and then times 2.
18.
Okay, yeah. That's a quick way you can do it, but do it any way you want. 54 divided by 3 is also 18. And then, what's 3 squared?
9.
9. 9 times 3.
27.
And 27 divided by 2.
I don't know. It's
13.25.
Yeah, sure, 13.5.
Yes.
Because we need to find C. You could have left it as a fraction if you want, but this is going to make
Plus
it
C.
easier, isn't it? Yeah, plus C. So we're going to solve for C next, or soon.
8.
Yeah.
That's
What's 18?
4.5.
Is it?
Yeah.
I believe you. 4.5 plus C. C going to equal.
C equals 8, subtract 4.5.
What's that? Is it 2.5?
No, that's 3.5.
Ain't that 3.5?
So, we've found our wonderful C. So C, you could say it, or C, what would that be as a fraction out of interest, if you wanted over 2?
3, 2 over 3. 3 over, oh no.
What's divided by 2 is 3.
6 over 2?
It's
Just out of interest.
7 over 2. 7 over 2.
Oh,
I
okay.
knew that. I knew it.
So notice we don't just want C, we want the whole function again with C subbed in. So you could sub in 3.5 for C, that's fine, or if you want it as a fraction, because the other two figures.
I like
decimals. I just don't like it how see how I've got that there? I don't know what that's doing there, so I'm just going to get rid of that. I'm not going to erase it. So now we've got to write the whole displacement function. You can find the expression for S in terms of T. Our final answer is S equals 2. You could write 2/3 T cubed, or you could write T cubed over 3. Same thing, you could write minus 3 over 2 T squared, or 3T squared over 2. And,
She can't see you, Jamie.
right. So notice because they wanted the final thing. This thing.
Oh, okay.
Yeah, they wanted the final thing. So I've just rewritten that with the C subbed in.
Could you also write it 2t cubed over 3 subtract 3t squared plus 7 over 2?
Yeah.
Isn't that just what you think?
Yeah.
It's just, I just don't like it.
What some people like to do too is have a common denominator. So the common denominator would have been 6, wouldn't it?
Yeah, that's
Do you want to try doing that?
No.
I don't want to do that.
Not at all.
I wouldn't do it.
We don't have time for that.
That was a definite no. So that would be 4t cubed minus 9t squared plus 21 all over 6. Am I right or wrong?
I don't know.
You don't know, you don't care. I want to do it.
Ice. Why did you put ice?
Ice, baby.
Ice.
Ah,
It's not like, can you explain the
I'm
joke?
behind those school.
oh, yes, yes. That's a good one. So just saying. Right. So what is the joke? What is the joke? Let's see. Where's the joke? Is it on the next page? Is the joke on the next page?
Yeah.
You got
Sorry.
ice.
My mind's just based on Scroll down to the bottom. There you go.
Okay, so integral
There.
integral of ice cubed with respect to ice. So instead
But
of
it's not cute.
oh squared, sorry, 3i squared. Think of it. Ice as being x.
It's ice cube.
Yep. So what would be the new
Ice
It's just gonna
cube.
be ice cube.
3 ice? What would be the new exponent? Ice.
We do it 10, but
3 ice
yeah.
What would be the new exponent on the ice?
cube.
3.
3.
Oh, 3.
With an ice cube.
So what is the dice? Is that just the dice?
What does that mean?
So, do you know that Spanish famous person?
Yeah.
It's so funny.
That's funny. I like that one. That was funny. Like
They should have had a picture of him or something.
Yeah,
That would be better.
Actually, I was thinking about the ice cube and not the ice cream.
I suppose, yeah. Maybe it's not meant to be the wrapper. Maybe it's in the active. Maybe it's meant to just be an ice cube. Okay, let's do this. Here's another one. Velocity v of a moving particle at time t seconds is given by blah blah. This is a nice linear one this time. Find its acceleration. Do I need to integrate? The derivative. How do you know it's a derivative?
It's going down.
Yeah, velocity. Velocity to acceleration. So find the derivative. You need to differentiate. That's why I've tried to put in one where you have to decide is it integrate or differentiate. Differentiate. Because by now you can get confused. What's a nice symbol? Oh no, acceleration. So let's just call it A. Whatever.
Okay. DVA.
Awesome.
I think they've got it A with A bracket T. A bracket T is what they call it. A. So what is it? Hard that now you've been integrating. It's hard to think, isn't it?
Is it 3?
It's something really simple.
3.
Negative 3, kid, yeah. Just negative 3 is a number. And what's its unit?
MS.
What?
-1.
Acceleration is like meters per second square, but you might not know that, that's okay. So the way you write in the physicsy way, you write ms minus 2. They probably wouldn't have cared.
Are those minus? Okay.
Yeah, so ms minus 2 is just the units.
Do we have to know that?
I don't think so. I don't think it's required.
Yeah, that's
Because they don't assume you've all done physics.
physics.
Yeah, I do physics. But
You don't even need to do that.
yeah.
Was there all that room just for that one?
Yeah.
I hate when it tricks my brain.
Yeah,
I
yeah,
have
tricked
to
you.
let her do more stuff.
So now find the initial. Notice the initial at time. When I say initial, what time is that?
0.
Good, yeah. So that's something you might just want to be aware of. T at time equals 0. Because some people forget that actually gives you a value of t. The displacement S equals 4. So we've got a nice little coordinate. Find an expression for S in terms of t. So we've got a lovely little coordinate like we did before. So I'll just write that. So I'll write the coordinate 0, 4. And that's like our x. It's as if it's x and y, but it's not. It's s and t this time. So you could think of it as t and s, if you prefer. We've got to. Do we have to integrate or differentiate the velocity to get the displacement? So velocity's up here. Integrate, yeah, good. So we need to integrate this time. And then we're going to solve for c. So you need to integrate, not the acceleration of course, but the v. Yeah, good, yeah. Let's integrate that. So it's 15 minus 3t. That's a nice easy one to integrate.
Why does the calculus even have to do with all these velocity and speed and this?
3t.
No. Yeah, but I mean, why does it have to like why?
I'll just move it on there.
Why are we connecting that to calculus?
So the displacement s. Let's call it s with respect to t. It's not too bad wrong if you just call it s.
15t.
What was it again? I forgot the original.
It's 15 minus 3t.
Oh, okay, yeah, 15t.
15t
15t minus.
3t squared over 2 plus b.
Nice work. Yeah, because it's hard when you jump from integrating and differentiating. It's hard in your brain, isn't it? So 15 becomes 15t when you integrate it. Minus 3t becomes minus 3t squared plus c and all that stuff. Now we've got to sub in the coordinate and solve for c. And then just rewrite the displacement again with, oh dear, with it subbed in. Okay, so let's do that. Let's sub in.
Is it 0? I mean, negative 4.
4, yeah, equals 15, 0.
Let's see what we even negative 4.
Let's see, that's a good point. So Kieja's noticed that that's going to become 0, that's going to become 0. So you could just write 4 equals C.
I thought I knew it was all cancelling
Overcomplicated. So 4 equals C, have I finished? Have I got my
We
answer?
have to plug it back in.
Yeah, plug it back in, yeah. So good. So S, you could just write S if you want. Some people might write S of T. Because the one above said V of T, so I'm going to write S of T. Stating with respect to time equals 15T minus 3 over 2T squared, or 3T squared over 2 plus 4. What just happened? Why? Yeah, perfect timing almost. Plus, hello, why? Why do that to me? Plus 4, it's meant to say.
Part 4. Finito.
Can you hear?
Adios.
Plus 4. What's another way I can do it then if it's not going to write? And I'm trying to make it plus 4. Why isn't it writing it? Plus 4. It's meant to say plus 4. So if you're not listening to me, that's too bad.